Hello everyone, welcome to the lecture series of Power Plant Engineering. Myself Dr. Vipul M. Patel from Dr. Subhash Technical Campus. So as we have discussed in the previous lectures, Dalton's partial pressure law, same as in today's lecture we will learn about the cooling towers. So what is the necessity of cooling towers, applications of cooling towers, types of cooling towers used in steam power plant, and importance of the cooling towers. So first of all, we are going to start about cooling towers and necessity of cooling towers. See, most commonly wet and recirculating systems use cooling towers to expose water to ambient air. Some of the water evaporates and the rest is then sent back to the condenser in the power plant. Dry cooling system use air instead of water to cool the steam, exciting a turbine. So it is the necessity of cooling tower. See, in the steam power plant we are using cooling towers, and I hope you have seen the different cooling towers in steam power plant. So in this steam power plant we are using wet or recirculating systems to use cooling towers to expose the water to the ambient air with the use of the evaporation process. So it is the important to cool the water, and again if you want to reuse and if you want to send back to the condenser for reusing the cool water, we have to use cooling towers, right, in the steam power plant. So dry cooling system is also used air instead of the water to cool the steam existing a turbine. Now condensers water cooling system, mainly there are three different types of cooling system which are commonly used in practice according to the availability of the water are listed below. First one is an open or once through system. Second one is a closed cooling system, and third one is a mixed cooling system. You can see in the next slide what is the meaning of open or once through cooling system. See, in this type of open or once through system, all the required quantity of the cooling water is withdrawn from the source of the water. Source of the waters like sea, rivers, lakes or well waters. Try to understand, in these systems all the required quantity of the cooling water is withdrawn from the source of the water like sea, rivers, lake or well water. For entire plant cooling duties in the system, the water is drawn directly from the upper stream. In this system, the water is drawn directly from the upstream side of the river, water pumped through the condenser and the discharge, and then discharged to the downward side of the river at a temperature 5 to 100 degrees Celsius in the excess of the inlet temperature. So the temperature of this discharge water should be kept within safe limit to prevent the harm of the fishes, and the limit of the discharge water temperature is specified by the fisheries board, and the arrangement of the open system is shown in the figure in the next slide. So try to understand the quantity, water of quantity required that we can directly withdraw from the different sources of the water, and the cooling duties in the system's water is drawn directly from the upstream side river. So which is already cooled water which we are withdraw from the river from the upper side. So we can directly pump through the condenser and then discharge to the downward, which is with the temperature, or we can say hot water. So near about 5 to 100 degrees Celsius temperature, the excess of the inlet temperature, and the temperature of the discharge water should be kept within the safe limit to prevent the harm of the fishes. So there should be some rules of the fisheries board. So if a higher temperature, if we can access that water and through it to the again sent back to the river with some higher temperature, then definitely we can say it is very harmful for the fishes which is in the river, right? So the limit of the discharge water temperature is specified by the fisheries board, and that the type of arrangement of the open system is shown in the figure that you can see in this slide. This one is a river, so cold water in from here with the use of the cooling water pump. We are using the cool water over here and sent back again to the river hot water. It is called once or open through cooling system. Once means one time used water, again it will send it to the river, or open system we can say that. Second one, it is a closed system. So the recirculating or closed cooling water system operate in a closed loop with fresh water makeup, which constitute only a small fraction of the cooling water circulation. So as we discussed open or once through system, and we already see the graph of that particular, like that in the next slide we will see the graph of this closed system or figure. You can see that closed system are of two types, water or air cooled type. Water cooling type employ cooling towers or cooling ponds, and air cooling type employ direct dry type cooling tower system or indirect air cooling system. Closed systems are mainly, we can classify it into the two categories. One is water and second one is air cooled type. Water cooling type employ with the cooling towers or cooling ponds. If you have to prepare cooling tower or cooling pond for water cooled system. But air cooled type employ direct dry type cooling tower systems or indirect air cooling system. When enough quantity of the water is not available for cooling requirements from the river, then the closed systems is universally adopted. As we discussed in the open or once through system, if required quantity of the water, we can easily, it is easily available from the sources of the water like sea, rivers, ponds, well, etc., then we can use it. But when the enough quantity of the water is not available for the cooling requirements from the rivers or other sources of the waters, then it is universally adopted cooling system. It is called closed cooling system, right? In the closed system, the hot water coming out of the cooling water used is cooled either by springing in the pond or passing through the cooling tower instead of discharging to the downward flow of the river. So in this system, the hot water coming out from the cooling water's user is cooled either by springing in the pond, if we can discharge it in that pond, or we can pass it through the cooling towers instead of discharging the downward flow of the water. जहाँ से हम विड्रॉ करते हैं वाटर को, उसके ऊपर साइड में हम इसको डिस्चार्ज नहीं कर सकते हॉट वाटर को, राइट? सो कहाँ करना है हमें? डिस्चार्जिंग टू द डाउनवर्ड फ्लो ऑफ द रिवर. जहाँ से हम पानी को विड्रॉ करते हैं फ्रॉम द रिवर, वहीं से हमें यूज नहीं करना है. If the quantity of the water required is from the river during flood period or when sufficient water is available with required quantity, required purity, and same water is used again and again for the condenser by passing through the cooling towers, such arrangement of the cooling system is shown in the figure that you can see over here. Understand? Make up water from the river. It is a pump. With the use of that, we can easily extract the water With the use of this makeup water pump, we can send it to the circulating pump. So with the use of this circulating pump, it is directly when we required cooling waters. It is a cooling water users like different equipment used in steam power plant like condensers, etc. And then again it is sent into the cooling towers, and then evaporation losses, so we can easily get the cooling water again and again. If in some situations of floods, मतलब जो अपनी रिवर है वो कंटिन्यूसली फ्लड में मतलब जा रही है, हमें वही वाटर वापस यूज नहीं करना है, then again we can use it from the river also, right? Another one is a mixed system, a combination of the once through and recirculating, or we can say mixed cooling water system is sometimes employed to carry out the process cooling via the closed cooling water, which in turn is cooled by a open cooling water circuit in a suitable heat exchanger, and the arrangement of the system is shown in the figure. You can see that primary circulation pump, cooling water users, again secondary circulating pump, it is a river or source of the water, we can say. Secondary and primary water circulation pump is over here and over here. It is a user of the cooling waters, again send it to this over here. This system is a mixed system, we can say. So with the use of that, we can easily send it to the hot water to the river, right? So this is the combination of the once through and recirculating or mixed cooling water system is sometimes employed to carry out the process cooling via the closed cooling water. Understand? The main advantage in the system is the flexibility of the operation it gives to the process side, which is on the closed loop. And another type of the mixed system uses river water as well as the cooling tower simultaneously. So this system overcomes the difficulty of the recirculation and meets the requirements of the fisheries board on the fairly small river. The arrangement of the system is shown in the figure. This is the source of the water, or means we can say river, cold water in, circulating pump or extraction pump. We can see over here cooling water users like condensers, and from here we can easily discharge to the downward side of the river, hot water out. But over here, when the required quantity is less from the water source, then again we can use this as a recirculating type. So we can send it to the cooling tower again, and those water, if we can directly discharge to the river, if we don't want to use again and again in the cooling towers and condensers, right? So this open or once through system, second one is a closed, and third one is a mixed type, right? Now the advantages of these systems: the size of the cooling tower can be reduced where the site area is limited. Second one is the quantity of the cooling water is required reduced as recirculation is eliminated, we can say. Third advantage is the turbine plant efficiency also increased. This system should be adopted only when there is a possibility of recirculation and it is necessary to meet the requirements of the fisheries board. So we have to fulfill the requirements of the fisheries board also, and the system should be adopted only and only when there is a possibility of the recirculation also. So these are the advantages. And then types of cooling towers. Cooling towers cool the warm water and discharge from the condensers and feed the cooled water back to the condensers. What is the application of cooling tower? With the use of the cooling tower, we can cool the warm water which is discharged from the condenser and feed the cooled water back to the condenser after the processes of to cool the waters which is from the condenser, which is coming from the condenser. Now there are different types of cooling towers are as follows. Mainly we can classify the cooling towers into the two categories: natural draft cooling towers and mechanical cooling towers. So as per the name, I hope you understand, natural draft cooling towers, we are using naturals to cool the waters which is coming from the condensers. It is called natural draft cooling tower. Mechanical cooling towers or mechanical draft cooling towers, it is also called. Why? Because in this type of cooling towers we are using a mechanical energy. And then also we can further classify the mechanical cooling towers into the two categories, that are those are forced draft cooling towers and induced draft cooling towers. So in that also we can further classify into the two categories. मैकेनिकल को हम दो कैटेगरी में डिवाइड कर सकते हैं, फोर्स ड्राफ्ट कूलिंग टावर एंड इंड्यूस्ड ड्राफ्ट कूलिंग टावर. So first of all we will discuss about natural draft cooling towers. Natural draft, which utilize buoyancy, is the force exerted on an object that is partly immersed in the fluid via tall chimney. Warm, moist air naturally rises due to the density differential to the dry, cooler outside air. Warm, moist air is less dense than the drier air at the same temperature and pressure. So this most air buoyancy produces a current of air through the tower. So these photos in the next slide shows a single natural draft cooling water as used at a European plant. In the natural draft cooling towers, it is very typically about the 400 foot or near about 120 meters high, and depending on the differential pressure between the cold outside air and hot humid air on the inside of the tower as the driving force. No fans are used because it is natural draft cooling towers. It is not a mechanical draft cooling towers. So the green flow path show how the water is taken from the river to an intake supply basin that the circ water pumps take suction from them, and the water is then pumped to the condenser where the water is heated. The water is then sent to an exit distribution basin where the water can be returned to the river and pumped by the cooling tower pumps to the cooling towers. Then the water returned to the intake supply basin where the water can be reused. So those hot water coming from the condensers that will be collected into the cooling towers with the use of the natural draft cooling towers. Some evaporations process are also there and it will be performed in the cooling tower, and with the use of that process we can easily cool that water which is coming from the condenser. And also we can use, if you want to reuse that particular water, then with the use of the different pumps of the cooling water we can send back to the condenser. Which one? Cooled water, right? It is natural draft cooling tower. You can see the figure of the natural draft cooling towers. The structure, concrete structure, you can see the shape of this cooling tower or natural cooling tower or natural draft cooling tower is hyperbolic. Like hyperbolic shape is also there. Height typically 350 to 500 foot or near about 120 meter is also. So you can see what is the working of the natural draft cooling tower. The natural draft cooling tower or hyperbolic cooling tower makes use of the difference in the temperature between the ambient air and the hotter air inside the tower. It works as follows. Hot air moves upward through the tower. Definitely hot air moves upward through the towers because of hot air always arise. So fresh cool air is drawn into the tower through an air inlet at the bottom. right? Due to the layout of this tower, no fan is required and there is almost no circulation of the hot air that could affect the performance, because this is a natural draft cooling tower. We are not using a different fans, and concrete is used for the tower cell with the height of the 200 meter up to 200 meter, and these cooling towers are mostly only for large heat duties because the large concrete structures are very expensive. So this is the natural draft cooling tower. Now air drawn across falling water field located outside the tower. It is a cross flow. Air drawn across falling water field located outside the tower, and over here air drawn up through falling water field located inside the tower. So you can see the natural draft cooling towers. It is a air in, hot water inlet. Over here it is a cold water collecting basin. It is a cold water collecting basin is over here. In that, air drawn up through falling the water. From here air in. It is diagonal columns. Over here you can see hot water distribution basin is over here. Diagonal columns is over here. So reinforced concrete cells are over here. This is the vertical ribs, hyperbolic shaft, upper system beam. It is a void. Hot water distribution system is over here, and rift eliminators is over here. And this is the fill annular areas, and vertical ribs are over here. So this is the cross flow and counter flow. Now mechanical draft. Mechanical draft towers have large fans to force or draw air through circulated water. So the water force download over field surface, which help increase the contact time between the water and air, and this help the maximize heat transfer between the two. Simple, try to understand. Mechanical draft towers have large fans, mechanical fans, to force or draw air through circulated water. Those water, hot water coming from the condenser, and the water falls downward from the top. So downwards over field surface, and which helps to increase the contact time between water and air. And this helps the maximize heat transfer between the two. Two means air and water. So cooling rates of the mechanical draft towers depends upon the various parameters such as fan diameter, speed and speed of the operations, and fields for the system resistance. Cooling rates depends, or of the mechanical draft cooling towers depends upon the various parameters such as fan diameter. So which type of mechanical fan we are using, the diameter of this fan, and speed of the operations, field for the system resistance also. So mechanical draft towers are available in the large range of the capacities also. The towers can be either factory built or field erected. For example, concrete towers are only field erected. So those mechanical fans we are using in the cooling towers or concrete towers, we can say we have to put it as a field erected. Otherwise, we can use the factory built fan also. So many towers are constructed so that they can be grouped together to achieve the desired capacity. Thus, many cooling towers are assemblies of two or more individual cooling towers or cells. The number of cells they have, example, 8 cells tower often refers to the sub towers, mechanical cooling or mechanical draft cooling towers. Types of mechanical cooling draft: forced and induced. So first of all, forced draft cooling tower. You can see the figure. Centrifugal fan we are using, as we discussed in the previous slide. So depends diameter of this fan, speed, capacity of this fan, depends how it works, and hot water it is from the top of the surface, fills centrifugal fans, and again we will get the cold water from here at the bottom of the surface. So air blew through towers, centrifugal fans at the inlet we are using. Advantages is suited for the high air resistance and fans are relatively quiet. Disadvantage is recirculation due to the high air entry and low air exit velocity. This is the forced draft cooling towers. You can see forced draft cooling towers figure. You already seen in the previous slide. A mechanical draft tower with a blow type fan. At the intake, the fan forced air into the tower, creating high entering and low accessing air velocity, as we seen in the disadvantage of the forced draft cooling towers. The low accessing velocity is much more susceptible to recirculation, and with the fan of the air intake, the fan is more susceptible to complication due to the freezing condition. And another disadvantage of this forced draft cooling tower is that a forced draft design typically requires more motor horsepower than an equivalent to induced draft design. So here we require more horsepower motors. And the forced draft benefits is its ability to work with the high static pressure, so they can be installed in more confined spaces and even in some indoor situations. And this fan geometry is also known as a blow through. This is the advantage of the forced draft cooling tower. Now induced draft cooling towers. So there are mainly two types of induced draft cooling tower: closed flow and counter flow. So advantage of the induced draft cooling tower is less recirculation than forced draft cooling towers, because the speed of the exit air is 3 or 4 times higher than the entering air, right? So as we have discussed, the disadvantage of the forced draft cooling tower because of velocity, and then the exit air is 3-4 times higher than the entering air. This one is the most important advantage of the induced draft cooling tower compared to the forced draft cooling towers. So disadvantage is fans and the motor drive mechanism requires weatherproofing against the moisture and corrosion, because they are in the path of the humid exit air. So we have to remember that it will be weatherproofing or against the moisture and corrosion. So we have to protect it from the moisture and corrosion also. It is a figure of the induced draft counter flow. Hot water enters at the top, air enters at the bottom and exits the top. Uses forced and induced draft fans. So induced draft counter flow tower, induced draft counter flow tower with fill. So cold water from here, hot water from here, hot water from here, and cold water from here we will get. It is a fill. It is also induced draft counter flow, but it is with fill and it is without fill. Induced draft closed flow. So I hope you can understand with the use of the figure how it said by the cross flow. Water enters top and passes over fields. Air enter on one side or opposite side. Induced draft fan draws air close flow across the field, right? So in both induced draft double flow cross flow tower, induced draft single flow cross flow towers. Over here only there is one, here two, right? Induced draft cooling tower. Now it is the main important question, that is a natural draft cooling tower and induced draft cooling towers different. So it is the comparison between natural draft and cooling tower and induced draft cooling tower, we can say. So in natural draft, all these things we already discussed in the previous slide. Work on the principle of the chimney effect. Airflow is the natural and based on the exit and inlet condition of the air. In induced draft, cooling is accomplished by the draft of the air created by the mechanical fans. So no power required apart from the pumping of the water to the tower. Over here power for the fan operation is the additional requirement, because it is a one type of mechanical draft cooling tower. Maintenance free as far as rotary equipment are concerned. Over here regular maintenance of rotary equipment is required because we are using mechanical fans. Generally operates on very low water loading, but it can operate at a very high water loading up. And low operating field velocity, over here higher operating field velocity. generally operate where the load available is very near to the design heat loads, since at low loads the density difference becomes very low. Over here can operate at various load conditions also. Larger construction period we required in the natural draft cooling tower because we have to prepare it with the concrete construction, right? Much shorter construction period, especially since work can be carried out simultaneously on two or more towers. Here in the natural draft generally suitable for large water flows, and in the induced draft suitable for the all water flows. So thanking you. Chapter number 7, condensers and cooling towers, is over now. From the next lecture series, from the next video lecture, we will start another chapter. And thank you enough today. Thank you all.